Hello, it's day 12 and it's late. I'm in my noisy Airbnb. Well, I'm going to put the phone in the cupboard. Stop it digging into me. And we've got one which for some reason has caused me a certain amount of trouble thinking through today. Maybe it's just me, but I mean, we'll see. So, we've got a series of patterns, and each of these, well, actually, this is the pattern. We've got essentially this is the truth in a good way. We've got one, one, and three. Here we got one, one, and three, but they're depending on the pattern, they can be positioned differently inside the string. They can be sort of shifted along or one or more. There's always one between separating these blocks, let's call them spans. And the fun thing is that there are some that we don't know what they are, and we have to work out how many different combinations could go inside here. So with this one, we've just got, we could have one here, we could have one here, and that's it, because we've got to have one separating them, and then that's it. With this one, we know we're going to have three here, but then we could have two here and one here, and then a bunch of blanks, or we could have two here and then one at the end. Now, my combinations alarm, which I have embedded in my mind, is sounding with this one. The input is small. You probably could just generate every combination and just check off the ones that match. That would be the smart thing to do, potentially, and then let part two come as it does. But I decided today that I wasn't smart, and that I would instead really try to think through it. We will see how that goes. I have been puzzling through that. I say I'm puzzling through it all day. I've been doing other things. I've been out. I've been living my life. Get it? Just listen. It's okay. Don't look at this. Basically, I have learned a few things about this problem. I have tried, in principle, I think you could use regex to solve it. I could not make it work on the various online tools or in the REPL. And I thought there's this thing with overlapping. I'm probably going to get into trouble, so I just won't do that. Probably there's going to be someone out there with like an incredible one-line regex thing, which is very elegant and beautiful. That is not going to be me today. What I have learned is let's take this example. Ignore this. I don't know if this is true. Let's take this example. So what I have learned is that there are a limited number of gosh, how do I even start to explain this? Okay, let's choose a more complicated one. Let's choose this one. So you can represent this as, so we know what we know is there's going to be a block of three, a block of two, and a block of one. And we know there's going to be at least one dot in between. So this, ignoring the pattern, how do I make this go away again? Okay, just stick around, why don't you? Fine. If we ignore the pattern, this is what it could be. The quirk is that there could be, that there's definitely has to be, to match the pattern, some more dots in one or more of four places. So this is just to match the length. So I guess we can say to match blocks, this is what we need. Now to match the length, we need something else. We can say that there have got to be some more spaces at A, B, C, or D. or a combination of all of them. And to match the pattern, these have to be distributed correctly. So in this case, A is going to be, it has to be 1. B could be, we don't know, but it's, well, it's got to be something. C we don't know, D we don't know. But we do know that A plus B plus C plus D has got to equal a certain calculation. And the calculation is the length of the pattern minus the length of the blocks. That's 6. So this length, the length of this pattern is 12. So to get the, in fact, what are we calculating? A plus B plus C plus D is the length of the pattern minus the length of the blocks minus the necessary spaces. That's these dots here, which is 2. And well, that's it. So at this point, we can say that the sum of these is going to be 12 minus 6 minus 2 being 4. So these are our constraints. In this, in this case, we actually, let's just pretend we don't know this yet. In this case, in fact, this is probably more up here. So these have to equal 4, because if we were any longer than that, we would exceed the limit of the pattern. Okay, so this is starting to help us put some constraints on the amount of combinations we have to generate. The part that I've been slightly muddling away at is how now, if we were to try to calculate out how many combinations of the number 4 go into here, I don't actually know. I think it, over some patterns, could become quite large. You'd have to check quite a lot. We know there's going to be 4 0 0 0, 4 1 0 0, 4, no, sorry, 3 1 0 0, 3 2 2 2 1, etc. Lots of numbers. Maybe it doesn't get that long. In any case, I wanted to search for a way to match the pattern. And I do think I have an algorithm to do this. I don't really want to explain it. It's too horrible. So now, the first thing we do, roughly, is we say A equals, so let's go with let's call these bins. I've been calling these bins. Let's make bins 4 0 0 0. That would work in theory. But the problem with 4 0 0 0 is you end up with 1 2 3 4, this, and this. And this doesn't match what we know about. So that can't be true. So we decrement this, still doesn't work. Gosh, I need to use my computer better. Still doesn't work, still doesn't work, still doesn't work, till we get down to 1. At which point, let's just call this, say we've made this. In fact, we've really made this because we know there needs to be a dot straight after it. So really what we've made is this. If we just map out the part that we've decided. So in fact, let's start off with just 1. This is what 1 looks like. You can see where I'm getting confused. So this is what 4 would look like. We would need the pattern to start like this, and it does not. So we decrement 4 till we get to 1, at which point we have something that does look like the start of our pattern. So we can use this. The way we add to it is by, adding 3 here. If we add 3 here, do we get something that matches the pattern? Yes, we do. This still matches. Okay, so let's try adding 0. And then, of course, we need to add another 0 because we know it needs to add to 4, so we can't use any more numbers. So we have this, and then this. If I've not made any silly mistakes, this is our pattern. And this matches. So this is one combination. We have come up with one. Is this more? I don't even know if this is more efficient, really. We'll find out. Right, I may just go back to the ugly version. Anyway, so now we've come up with one combination, but one combination isn't what we want. So let's say we've got 1. This is our first one. Now we're gonna go back. We're gonna try this with 2. So we're recursing up. We've hit something. We can't go any lower than 0. We can't go any lower than 0 on the last one. Let me put this out this way. We can't go any lower than 0 here. So we're done here. We can't go any lower than 0 here. So we can only change this. Now we want to take this down to 1. In fact, I probably should have had this be 3. Yeah, in fact, it was 3. Sorry, getting confused. So we had this down to 3. Now we can take this down to 2. Let's try this with this. Now, with this outcome, we get this. Ignore the ellipsis sort of condensing. We get this. Does this match our pattern? Yes, it does. So we can keep going. Now, at this point, we've still got a 1 left to use up. So we put the 1 here. And then we would check that this matched, and of course it does. What is it? Yes. So now we get this. Does it match? Yes, it does. Okay. Great. So I've chosen the one with 10 in it, which is way too many, but basically this goes on. I think you end up with 10. I've not actually calculated all the way through because it's my propensity to make mistakes ends up overtaking me the longer I do this. I hope that in principle, this works. We turn on my other laptop. Yeah, so I hope if we keep decrementing and doing this funny logic, we end up with 10 combinations, and we don't have to check as many as we would if we had to generate them all. I'm not convinced. Nonetheless, we will find out. This is the algorithm in some form, some horrible form. This is my logic, which is not terrible. Now I'm going to make a bit of a plan. My plan is to now, okay, here, let me think. Let me think. How do I minimize the chances of me making a billion different mistakes here? I need to start with the record. And I'm going to start with grow, which is what's going to create the patterns. Actually, I'm going to start off with matches. I'm going to start off with, then I'm going to go with grow, and its job is to create a pattern so far along in the string so that we can match it with matches. and then gaps to place. And then do we end up with something that works? I don't know. If this works, then I'm going to go move on to state and then read line, or rather parse line, and then calculate. I'm going to give myself a pause. If this record logic does not work, I need to pause, go back to my plan, probably probably sleep on it, if I'm honest. Okay. Now I've got my other screen with our plan on. Hopefully it doesn't keep wanting me to upgrade to Sonoma, which it definitely will. And I'm going to switch over my screen share to my editor, wherever that is. I'm going to reset my timer and then need to hide these meeting controls, especially. I wish the show meeting controls button was not escape. That is pretty irritating that is the case. Maybe I'll just leave them on if they cause trouble. Anyway, let's find out whether it works. I will be shocked, honestly shocked. I will feel like some sort of genius if this works, especially first time. Okay, let's go. So annoying. And what is this? Don't need any of that. Oh, again, so irritating. Okay, to place. Let's get myself an example, the most complicated one. Ten, better be 10. Okay, now I'm going to go to matches. So for this, I think that's right. Okay. Does this work? Nope. Oh, no, it does actually work. Okay, great. Well, another victory for the history books. Okay, gaps. Yeah, grow. Grow. Okay, um, so this is going to be um, no wait. So let's go with nothing first. So nothing should get us nothing. Not that it matters. Okay. One should get us two dots, or some dots. Okay. This should get us now, because we've already got some spans in here. This should get us that. Plus, I know this is inefficient in Python, isn't it? Wait. This should actually get us this. Because we can know at this point, yeah, we can know at this point that we're going to have a block here. Yeah, we can know at this point. And then we can also know that we have an extra dot there. And then at this point, we're actually going to take 2 off here. We don't want the last one. Actually, this better be something like that. Well, let's just go straight first. Yeah, okay, so we don't know what the last one is. That's irritating. Well, I guess we can know if it's, yeah, we can know actually. Okay, fine. So at this point, we add on that. Is this going? And then we can add on this too. This is going to start off at 1. So bin 1 is here. And then bin what am I getting wrong? I've got something wrong. My mind is going off. Maybe it's this check that's off. No, it's definitely, yeah, it's definitely this check that's off. This should definitely be doing that. Okay. What is this range? Hey, range, son. I hate everything. Ah, fine, fine. Okay, great. So that one's good. Now this one, we add a 2 here. We should get, oh no, actually, we should get a, yeah, we should get another one on the end of here. Yeah, so we should actually have that. Then if we add another, if we add a 3 here, 2, 3, and then a 1, and then a dot, but it shouldn't be a dot because it's the final one. Yeah, so if index, if len self spans equals is greater than the index minus plus 1. Yeah, okay. 1. Okay. No, but actually that isn't true. That isn't actually true. It should actually be, yeah, because the final one, yeah. Yeah, if, yeah, so actually it should be here. It's, yeah. No, actually I'm right. I was right all along. This this is correct. And now if we add a final one, it should be that. Yeah. And then this is terrible. If len bins is greater than len self spans, and we do one final trick. How do you get the last item out of this? Is it really? No, it's not. Then we do one last trick to add this. And then we get, this is so not going to work. Oh my gosh. Okay, well, my test passed now anyway. Let's try and implement the final algorithm. Okay, we're going to do this. So the pattern minus the sum of the spans minus plus 1. And then gaps to place should be for this 5. Pretty sure. But it's actually 4. What's wrong here? That's 12. Oh, I've got the wrong pattern. Yeah, this one actually is 4. My calculation was right. Okay, and this one's combinations. Yeah, should be 10. Okay, great. Now, algorithm. Okay. This can't be, I've missed something important here. Something, at least an optimization. Okay, so now let me get something working. I think I'm gonna have to debug this quite maliciously. Okay. Let's go with gap. Okay, gap. And then we've already got block spans, so it's fine. Oh yeah, because we need to take one off the block spans every time. Yeah, okay. Ugh. This is definitely not going to work. Okay, so it's definitely going down. That's good. Matches is never returning. Okay, so let's look this up. We get to this. And then we're trying to calculate this, which is good. This works. So we get to this. Does this work? Yes. But we've got one too few, which is odd. We should be counting. Okay, 4. We got 3 dots to place. So we put them all here. We've got too many here. That's the weird part. We take off this. We've got this many left. Is that the right number? Yes. So we try this. And then we try this, which should work. Apart from we've added a dot on the end. So if the spans, let me check. Yeah, if the spans have just one length, so actually we don't need this at all. Is it always true? No, it's not. Apart from the tests. Okay, so let's go with this. But they're counting down outside. Yeah, so if spans is greater than 1, we add one of these. Okay. Then we reach this weird point where spans is out of range, which is on line 50. Why is it getting called like that? Okay, so it's taking off this, and it's taking off this, then it's taking off this. Then it's randomly got one on the end for some reason. All right, let me. It's gone through yes here. Okay, so that's why it's got another one in the end, because it hasn't matched them all yet. And it wants to put a hash there, which it can do. So it returns one, which is great. Okay, that's good. Now let's trying it with two. So it's going from here to here. It's got two left, so it tries this, which works. And then it also tries this and then a dot, which works. And then it goes round again. 0, 1, 0, 1, 0, 1, 0, 1. but it should be returning at this point. Oh, yeah. Okay, so it rets one. Yeah, and then it gets to this point. But it keeps recursing. Okay, so it gets this one, recurses down, returns one, it goes down to to an empty string here. And then for some reason it calls this again. It adds another one. It should be spans that I should. Okay, now, well, it works anyway. Let's, wow, I'm way over. Let's see if I can push for a bronze. How could I possibly manage this? Snatch victory out of the jaws of defeat, potentially. Uh, 6. Incorrect. Very incorrect. Oh dear. It's all ones. It's all ones. That can't be right. How can it possibly all be ones when I've put in exactly the right same data earlier? This exact record is in there. Oh, wrong trial. Well, indeed, that would do it. I hope. 21? That's the right number. Oh my gosh. Could we possibly? Could we? Is this right? The moment of truth, real truth. Not that thing you've seen on InfoWars. Too high. Okay. Too high. Too high. Okay. Let me check the trial again. One, 4, 1, 1, 4, 10. Okay, so the trial is right. What happens if we put in one where nothing is possible? Okay, you can upgrade now. Let's try this. 2. Now, is 2 the correct answer here? So we could have this is 4, 1, 1. We couldn't have that. And then 1, 2, 3, 1. And then, so this is, so if we're counting, all right, so 2. What possibly could the other one be? I don't think there are any other possibilities here. So this one is being counted as 2 for what reason? Oh, all right. So pattern is this. First, we take everything down to, no. First, we take everything down to this. No, wait, what is the, it is. We take it down to this point, which we notice is good. Then we try this. We have 3 dots to spend. Is that right? Well, anyway, let's see what the combinations come up with are. That gets put down to this. And then this. Which then gets returned as 1. If I add these up, well, that one works. 4, 1, 1, 3, 1. So there are 2. Yeah, well, that one's correctly detected. I mean, that looks right, doesn't it? That is right. Yeah. So that one seems true. 2. Yeah. So let me just verify this. We could put this here and then one of these here. That would also match. That's correct. So there are 2. There are 2 solutions here. Okay, let's try another one. Five. Okay, so it could be this, it could be this, it could be this, it could be this. That's four, right? Four possible patterns. Be good for it to get to print out the patterns, wouldn't it? And now there's loads. Oh, I need to. That last one is odd. Where's that last one coming from? It's recursing forever because it's not meeting the base case. This is fine. Okay, so we start off with 0. So in this case, we start off with 2 spans. We apply 1. We apply 1. We apply the next. We've got no spans left. So it just keeps kicking the span along. Which is not good. Let's continue doing again. Yeah, okay. So that's not going to make any difference. We're getting a ridiculously high number of results for some reason. Many of which are duplicates. Not especially happy with this approach, but it might at least get us a different number. All right, let's try that. 7506. Okay, that's part one. Simple. Part two. Replace the list of spring conditions with 5 copies of itself separated by question marks and replace this list of contiguous groups dimensioned by 5 copies of itself. Okay, so it's the same principle, it's just faster. I'm going to give myself a pause on this and then, yeah, we'll see how slow it is. All right, reset. Right, no, we'll count that as reset. Okay, and then it's going to be, let's go against that. Let's go with this times 5 and this times 5. And pretty slow. Also, just incorrect. Oh, right. So they're separated by question marks. Fine. Okay. Okay. 1, 2, 3, 4, 5. All right. Well, that's the correct answer. All right. Now I've got to work out really what the issue is with my code. Because we're now generating far more possibilities than we should. So yeah, that would take a while. That would take a while to do the input. All right, switching back against this, then let's look at why that's happening. All right, let me properly step through this. Okay. Is that 10? One, two, three, 4, 5, 6, 7, 8, 9, 10. Yeah, it is. So that's when we're done. We're not adding them up for some reason. Oh, this index is out of range. That's why. I assume. No. Oh, okay. So not all of these are right. Which is wrong? The first one is wrong. This one we're not getting very far at all. So now this one's right. Ish. What are we putting it as? Yeah, and that's the only one. This one should have 4, right? Oh, are we just doubling them? 1, 8, 1, 4, 8, 20. Not simplistically, no. This one's coming out as 8 for reasons we don't understand yet. Sorry if you can hear this music. It's really going off. Need some battery. Okay, I've done my horrendous debugging. Uh, will it result in a correct answer if I then do this? We will see. Is it even slower? God. Hmm. Let's try it. Really reflecting how my mind is at the moment. Oh, I think that's my fan coming up. Hmm. Not looking good. I don't quite get what's taking so long either. It's going to take forever. Yeah, it's going to take a long time. Okay, let's not do that then. I wonder how many it's checking. Hmm. It's checking quite a lot. What about on the original? 167. All right, this is going to take some thinking about. I'll come back to it. I've come back here to attempt once more. I've used some dynamic programming, keying in on basically everything it takes to generate the gaps. The insight that I had is that you can probably, if you've already seen this part in the string, and you know you've still got the same amount of things to go, you can the result is going to be the same. So you get the same number of combinations, provided you get the same. Anyway, I'll explain another time. Let's see whether we get the right answer. Hey, oh my gosh. Oh, that was an absolute ordeal. Okay. Right. So what I would like to do is I would like to explain myself, but I'm not going to be able to really. Let me tell you what I did. So the logic is very similar. I always get hung up on these dynamic program problems. The logic is very similar in that I'm very tired. I made some small optimizations before I thought about doing dynamic programming. I don't know. It took me so long to think of that. All right, let me basically the logic is the same as part one. The the I've made some small optimizations in an attempt to reduce the amount of sort of string manipulation as such I was doing. The eventual solution I will articulate to you now. So let's look at this one. In fact, let's look at this series of things. Now, let's consider these options, right? Everything else is the same. And in this example, it doesn't really matter, but everything else is the same. And if we're working forward from the left of the string to the right, the first thing we calculate is this one. We get to this point, index 6 in the string, and then we keep kind of calculating on. I mean, we don't really in this case because there's no question marks, but imagine there was. We keep calculating on. We've still got a 6 and a 5 to place. And so we go through the rest of the string, we calculate it all out, and we come up with the right number of combinations, and we're all good. Then we move down to the second row, and we just shift this block one to the left. And we've added a new gap to the right. But the rest of the string is still the same. So we don't really need to like recalculate it at all. As long as we're at the same index, we get the same number of blocks to place, and a few other bits of state are the same, then we can reuse the previous result. So what this allows us to do is, well, do things much faster by saving the previous results. Hence, dynamic programming, that is the name of that technique. I understand it. The code is horrible, but it does work, and I am tired, so I'm going to do a quick edit on this video and then go to bed. Have a good night. See you tomorrow.